Mr. Mulholland here today again. This, I think, is going to be my final Solidworks lesson for you in this style where we're making parts. This is going to be a slightly longer video than usual because we are going to be making 5 parts and we are going to be making an assembly. So today what we're going to be doing is we're going to be making a birdhouse. So let's get started. We'll open our first part, just like usual, new part. See, we'll check our measurements. Yes, we're correct there. And we'll double check up here. Document properties, units, and we're correct there. So we're going to start by making the side of our birdhouse. And we're just going to, just like usual, do our center lines straight up and straight out to the side. So we're going to be making quite a basic style birdhouse, but as you can see, it can get quite complicated when you take into account all the parts. So let's get started. I have already actually made this birdhouse and worked out all the dimensions for you, and you should be able to find all the dimensions for this birdhouse on a document that will be attached to this page called Working Drawing. So we're going to get started by firstly drawing our box, and we're going to put a nice little angled roof on the box. This is going to make the side of our birdhouse, and the birdhouse is going to have 2 sides, but they're going to be both the same, so we need to make one side. So let's get smart dimension. It is going to be 90 millimeters tall, and it is going to be 100 millimeters wide. And the angle is going to go from the top corner to 70 millimeters from the bottom corner. When we have that, we can just trim our entities, and we're going to extrude this. We're going to extrude it by 5 millimeters, and we're going to give it a nice texture. We're going to be making a wooden birdhouse. So to find the woods, we go into our appearance, and it is under organic, and we look for our woods. I am going to choose pine, because probably if you're making something like this in school, the odds are you'd be using a pine. So that's our first part, so we're going to save this. Let's see. We're going to make a new folder for it, and we're going to call it birdhouse. And we're going to call this part side, so S-I-D-E, and we're going to save it. Now, we're not going to close this part, we're going to keep it open, but we're just going to minimize it. And now we're going to open our next part, which is going to be the front. So, check our dimensions. Yes, we're correct there. And we are correct there. So, let's get started. So we're going to be doing the front of the birdhouse. So I'm going to do this on the front plane, and we are going to do our center line just like usual, straight up and straight out to the side. So let's get started. We are going to draw our square that will become the front of the birdhouse, and this square is 80 millimeters wide, and it is 70 millimeters tall. So what we need to do now is we need to extrude this, and we're going to actually extrude this by 5 millimeters. And there we go, we're nearly there. So this part actually attaches with a butt joint. So we're going to make a smaller square on this square and extrude it to form the corners of our butt joint. I'm going to draw another little square within that square, and I'm going to make it 5mm away from this side, and I'm going to make it 5mm away from this side. And then what you do when you've that done is you extrude boss base, and we're going to extrude it by 5mm again. Now we're nearly done this part. Only another 2 steps. We need to make a little hole for the birds to come in and out, and we need to add a little fillet. Now the fillet is a new feature, but it's very simple. So we're going to go to our sketch, and we're going to click on the face we're looking to cut our hole on, which is this one. And I'm just going to draw the little circle anywhere on that face, and I'm going to smart dimension it to be, let's say, 35mm away from there, in the center, and we are going to go 20mm away from there. And we're going to give this circle a radius of 37. Great, when we have that, what we're going to do now is we're going to extrude cut, and that is going to cut this circle. We're going to cut through all, and that's going to cut this circle out of the material. And you can see that's give us a nice little opening for birds to fly in and out of. So what the last part we need to do now for this piece is we need to fillet, and that's just as simple as clicking the fillet feature. And the way the fillet feature works is it adds a rounded chamfer to an edge based on a radius. So this is 10mm wide, so I'm just going to keep this as 10, and I'm going to select this edge on the front of the front piece, and there we go, we have a nice little curved edge on our piece. So we're going to save the second part, and I'm going to call this front. Just like last time, we're just going to minimize this, and we're going to open a new part. And the next part we're going to make is the back part. And this has a variation of the fillet tool in it. This actually has a chamfer in it, and it's very easy to use as well. So let's get started. Check our dimensions. Yes, we're correct there. And drawing properties, units, and we're correct there. So let's get started. We're going to draw this on the front plane as well, and we are going to do our little L shape in the center lines, straight up and straight out. Great. So we're going to draw our rectangle, and this rectangle is going to be let's see, 80mm wide and 90mm tall. Now I'm going to extrude it. This time I'm going to cut out the butt joint instead of using another extrusion, just to show you that there are different ways of doing the same thing. So what we're going to do is we're going to sketch. We're going to select the face we're sketching on, and we are going to just draw what we're looking to cut. Smart dimension, and this is going to be 5mm wide and 5mm tall. And you can see I have just drawn that towards this corner. And another useful thing you can do sometimes is you can mirror entities. Select what you're looking to mirror, and you can select what you're looking to mirror it along. And actually what I need to do is to do that, I need to draw a nice little center line on the middle of my shape. So we're going to choose our entities to mirror, which is the square, and we want to mirror it about this center line in the middle of the shape. And you can see that just gives us a mirror image of this sketch on this side. So we're going to use our features, our extrude cut, and we are going to cut through all. There we go. Now we have our butt joint cut out. So next what we're going to do is we are going to make a chamfer. And the reason we're making this chamfer is because it will make it easier to fit our lid on later. So where do we get our chamfer? We go into features and we go underneath the fillet tool. There is the chamfer tool. And what we can do is we have two selections. The first one is how long we want to chamfer, and the second one is the angle we want to chamfer at. And what we need to do is we need to click on an edge that we want to chamfer. In this case, it is going to be this edge. And we select how far we want it to chamfer. And in this case, I want it to chamfer 5mm to put it up. And I'm happy with it at 45 degrees. Green tick. There we go. Part 3 is done. That's our back. Now we're on to our fourth part, which is going to actually be the bottom of the birdhouse. So let's get started with that. Open a new part. Check our documents. Yes, we're correct there. And we are correct there as well. So we're going to open our sketch and we're going to do this on the top plane. Just like usual, center line. Straight up, straight out. And we are going to draw our square. And we're going to dimension this square to be 80mm tall. And it is going to be 110mm wide. In case you're wondering, I'm just looking at the same working drawing that I have given you. That's why it sometimes takes me a wee bit of time to find the dimensions I need. And what we're going to do is we're going to extrude this part, this shape, and we're going to extrude it by 10mm. And now what we're going to do is we are going to make another square, another rectangle inside this rectangle. And what we're going to use that for is we're going to use that to make a pressure fit, with the sides of our box, with the sides of our birdhouse. So we're going to just draw another little square on the inside of that square. And this is going to be 5mm away from this line. It's going to be 5mm away from this line as well. And this side is going to be 5mm or 10mm, sorry, away from that side, and we're going to do the same at this side. So doing this gives us a nice sort of offset square that we know that this side is going to be 90 and we know this side is going to be 60. It cuts out the extra step of having to pre-dimension the side by setting the distance from each side. You could have originally dimensioned these two sides and then positioned it using the sketch, using the smart dimension, but this way is a wee bit more accurate. So what we're going to do is we're going to extrude that by 10mm. And there we go, we have our bottom. We're going to save that, and we're going to call this bottom. So now we're on our final part before we get to our assembly, and that's the lid. So let's open a new part. And let's check our dimensions. Yes, we're correct there. And we are correct there. Now, even though this lid sits at an angle, it doesn't mean we need to draw it angled. This is something that a lot of people struggle with in SolidWorks. But even though something maybe sits at an angle in assembly, we should still make the part as a flat part, and then when we assemble it, we will angle it. So let's get started. I am going to do this on the top plane, and I am going to draw my little L shape with my center lines, straight up and straight out to the side. So let's get started by drawing our square first. And this square is going to be, let me get a look. So this square, I'm actually going to have to use the smart dimension. And do you remember before in previous lessons I was saying it sometimes is handy, instead of typing in an exact dimension, to type in the formula or the sum that will equal it. This is exactly one of them times, because I can see there is a key dimension missing from my sketch, but I can make that dimension using a couple of other dimensions. So what I'm going to type is, I'm going to type 91.24 plus 15 millimeters plus 15 millimeters, and that gives us the total size of this part. And let's get a look. We're going to need to do this again for the other side, which is going to be 70 plus 10, or 70 plus 5 and 5. It's going to be 80, but we'll just do it this way. And what we're going to do is we are going to extrude this by 5 millimeters. There we go. We have our first part. And just like the bottom, we are going to leave a lip around the shape to help create a pressure fit. So let us sketch on this page, and we're just going to sketch another little box, and we are going to be, let's see, 15 millimeters away from this side. We are going to be 15 millimeters away from this side. We are going to be 5 millimeters away from this side, and we are going to be 5 millimeters away from this side as well. And let me just double check all that. 5, 5, 15, and 15. Yes, we're correct. So let's extrude that, and we are going to extrude that by 5 also. Now this piece also has a chamfer at the front of this box, and the reason I had to put this chamfer on was to stop it interfering with the front of the birdhouse. So remember how to do our chamfer. We go under fillet, and there's the chamfer tool, and this chamfer is 5 millimeters, and it is 45 degrees, and look at that, we're already set up for it. And we are going to click that edge, chamfer, and there we go, we have our lid. We're going to save that part as the lid. Now we've got all our parts, and all our parts are still open. So now that we have all our parts made, what we're going to do is we're going to assemble them together. To do this, we're going to open a new assembly. See, because we have left these parts open instead of closing them down, all our parts are sitting here waiting for us to use in the open documents. So the first part I'm going to bring in is my side, and this is going to act as the anchor part for everything else. So we're going to bring in our one side first, and we are going to bring in, I'm going to bring in the front part next. And now I'm just going to use coincident mates to get these two edges lined up with these two edges. So let's look. We're going to go coincident, and we are going to make this edge line up with this edge. Green tick. And we are going to make, let's see, this face. Let's go back. So we're going to make this edge. Oh, let's just unselect everything first. Close our mate. Sometimes mate can be a wee bit buggy like that you just need to close it and go again. So we're going to choose this edge and this edge first. Green tick. Great, so now we have that and that edge touching. What we need to mate next is this face and this face to stop it rotating. So now we have stopped rotating. We have it roughly in the right position, so we need to lock the up and down movement on it, and that's very simple. We are just going to mate this point, this corner. Actually, we're going to use the edge for this because I think it's going to be a little bit easier, to this edge. There we go. So we have our first part in, first two parts in, and made it up that they're fully defined with no more movement. What I'm going to bring in next is I'm going to bring in the second side. Now, because of how we have designed this, we can use the same side twice. So that's what I'm going to do. And when we have brought in the side, we're just going to mate it up again. Mate, coincident. Let's go for this face and this face. Great. And we are going to go for this face and this face. And let's get you and you. And now we need to get it lined up to the bottom. There we go. And we're nearly done actually at that, believe it or not. Doesn't get much more difficult. So let's bring in the back piece. And what some people actually think is you need to mate everything to everything, and that's not correct. What I'm going to do is I'm going to mate this to one of these two sides, and if we have it correctly aligned, it will be in place perfectly and not move. So let's get started. Let's mate this face to this face. Let's mate this face to this face. And let's mate this face, this edge to this edge. And there we go, that should be locked in place now. You can see you can't click and drag it anywhere. So that mate is fully defined. And you can really see we're starting to get our birdhouse together. The next part I'm going to bring in is I'm going to bring in the bottom. So insert components and bottom. And you can see why we made that lip now, to create a pressure fit around the bottom of the birdhouse. So let's mate. And what we're actually going to mate is, we are going to mate this face to this face. And we are going to mate this face to this face. And we are going to now mate this face to this face. And simple, 3 basic mates should have any part fully defined. And you don't always want it fully defined, remember, because maybe you have moving parts. But in this example, you really don't really want anything to move. And really, for any GCSE or A-level project, I can't see that you would need to leave any part particularly moving. Perhaps you might want to show off a drawer or something in a desk that you might be making as your project, or a table. And the way I would actually do that is I would make a new assembly of just the drawer and show it off like that in my file, in my folder. So now we need to bring in our final part. This is a bit more tricky because remember I was talking earlier about the angles. So let's go for the lid and let's bring in our lid. So the first thing I'm going to do is I'm going to make this the right angle. And this is very simple. We're going to use a parallel mate and we are going to mate this line, this edge, and this edge so that they're parallel. And I'm going to use this button to change the direction, hopefully. No, unfortunately it's not looking to do that. So we're going to have to use a few more mates to get this to do what we want. So next what I'm going to do is I'm going to use coincident on this face and this face. And this time, if I flip it, yes, it should be the right orientation for what we're looking. So we have our first 2 mates. What we need to do now is we need to line up. We need to make a coincident mate, between this face and this face. And we are 1 mate away from fully defining this. So what I'm going to do, I'm going to move this to make it a bit easier on myself, is we're actually going to mate an edge to a face. So we're going to do a coincident mate on this edge, and it is going to be coincident to this face. And that means that edge is touching that face. And there we go. We have our nice little birdhouse. What we can do now is, if you wanted to, you could have put the texture, the wood texture, on each individual part, like I did for the first. But what I'm actually going to do is I'm just going to apply it to the whole. Oh, I need a close mate box. What I'm going to do now is I'm just going to apply the wood rendering to the whole assembly, just by clicking and dragging on each part. And the final part. There we go. This is how you make a nice little simple pine bird box. Now what you can do is you can use a sectional view, and you can inspect just to see, look, there's nothing colliding with each other that shouldn't be. There's no overlapping of parts. The important thing is, in Solidworks, you need to be quite precise with some things so that it'll work in the model. In real life, it isn't always the case. You know, in a part like this, you wouldn't necessarily have to be precise with making sure this is a 5mm chamfer with a 45-degree angle, or that this is a fillet of 10, radius of 10, a fillet with a radius of 10, sorry. As well as that, you know, there's wee small things that you could probably do a bit easier in real life than Solidworks. But the advantage with Solidworks is you can really test out your design and see the type of issues you're going to encounter. So I didn't think that there would be any interference before I tested this part, before I made this part and tested it. Originally that was just a straight edge with no chamfer, but what was happening is when I brought in my final part, the two parts were overlapping, and I knew obviously then that wouldn't work, and if it didn't work in Solidworks, it wouldn't have worked in real life. So that is probably my final lesson where we're making parts. What we're going to be focusing on maybe the next lesson or two is we're going to be looking at how to create a working drawing, which is very useful because you can use a working drawing to go into the workshop with and take dimensions and precisely measure from a working drawing. As well as that, a working drawing can actually be used to make a template if you have your scale set to 1:1. So get experimenting with your SolidWorks, try and make this birdhouse, and just give it a go. Thank you, bye.